So here we want to simplify the expression, and we have tangent of, remember that an inverse trig function equals an angle, so we'll call that one alpha, and minus sine inverse here, so we're going to call that one beta. So it looks like we have tangent of alpha minus beta. Now you've got a couple of options. If you remember the tangent difference formula, you can use that. If you don't remember that, you can express tangent of these angles as sine of the difference of the angles over cosine of the difference of angles, and use those sum and difference formulas for sine and cosine. And whichever one you choose to do, you will end up getting the same answer. So let's go ahead and write the tangent formula for a difference. It is tangent of the first angle plus tangent of the second angle over 1 minus the product of the tangents of those angles, so tangent alpha, tangent beta. So what I'm going to do is I'm going to make two triangles, one for alpha and one for beta, and I'm going to set them up so that these inverse trig functions are true. So my alpha, I have cosine of this angle. It needs to be square root 3 over 2. That's positive, so I'll make this angle in quadrant 1, turn it into a triangle. There's alpha, and cosine is adjacent, square root of 3 over hypotenuse 2. Now I can go ahead and figure out that other leg with the Pythagorean Theorem. Square root of 3 squared is 3, plus b squared is going to equal 4, which is 2 squared. So I subtract this, b squared is 1, square rooted, then that's going to be a 1. Now I'm going to make a triangle for beta. That triangle, the sine of this angle beta is negative. So that tells me I'm in quadrant 4, where the sine is negative on the inverse sine. And so this is beta, and here's my reference angle. And I'm going to set that up so the opposite over hypotenuse, that's sine, so negative 3 over hypotenuse is 5, and I recognize that as a 3, 4, 5 right triangle, or you could use Pythagorean Theorem. So this is our triangle for beta. Now I can just go ahead and substitute in the pieces. So I need tangent of alpha. I go to the alpha triangle and I do opposite over adjacent. So that's 1 over square root 3 plus tangent of beta. I go to the beta triangle and I do opposite over adjacent, and that's going to be, I'll change that to a negative 3 over 4, and that's divided by 1 minus the tangent of alpha, and I already had that. That was that 1 over square root 3 times the tangent of beta, which was negative 3 over 4. So let's see what we could do to simplify that a little bit. If I get a common denominator, this is going to be 4 minus 3 square roots of 3 over 4 square roots of 3. So what I did there was I got a denominator, times these both by 4, and times these both by square root of 3, so that I could combine those. Now in the denominator, this is going to be 1, minus to minus will make a plus, 3 over 4 square roots of 3, and so I can combine those, and it will be 4 square roots of 3 plus 3 over 4 square roots of 3, because basically what I did was I took this and multiplied by 4 square roots of 3 top and bottom. And so now I could take this complex fraction. I could see these are going to reduce, because if I flipped it over, the 4 square roots of 3 is in the numerator, and the denominator is 4 square roots of 3 plus 3. And as I look at that, I can see that these two cancel. So my final answer is 4 minus 3 square roots of 3 over 4 square roots of 3 plus 3. And you can write that. I could have turned those around so they were kind of in the same form, but it's okay like that as well.